Second, I know you guys wrote down SSA, side-side angle, painful case, right? But was it that bad plugging in as long as you put sine of A on top? It might have felt a little bit weird because we reoriented our formula. The reason we reoriented our formula is because yesterday, remember, I mentioned with your formulas, there are two different variations. They're super, super similar. This one's just the reciprocal of the first one. If you're missing a side, if you have to go for a side first, then have the sides be on top. If you're missing an angle, you have to put the angle on top. And the reason we're missing an angle is because law of sines needs an angle with a corresponding side, an angle with a corresponding side. And whether you drew a picture or whether you just looked at the information, did you guys notice that we had an angle B with a side B? Yep. So that's going to go right here. Good, perfect, it's a number. So I had to go for angle A because it was the only other piece of information I had. For C, I'm totally stuck right now. I couldn't solve for angle C or side C right now because I can't use Pythagorean because this isn't a right triangle. What's it called if it's not a right triangle? Oblique. It's an oblique triangle. No guarantees of having a right angle. So when you guys plugged in, hopefully, all over 4.5 is equal to sine of, did you guys have to remember how to do minutes? 6.8. Yeah, you can just plug it into your calculator if you remember where the minutes are. Where are they? Second apps under the angle menu. Yeah, you could find the minutes there. Careful, you have to label the degree first and then label the minute. There is another way. The other way is to actually take this angle and say, hey, do you remember how minutes are 60ths of degree? You could do a little baby bridge, little baby dimensional analysis, but you could totally just use the second apps menu, and that's totally fine. That's one of the other reasons I had you guys go ahead and collaborate in groups, because you had to remember where minutes were. Okay, but besides that, how did you guys solve? Did what math, though? Good. Multiply 4.5 to the other side like we were doing yesterday, right? Multiply to the other side. Hold on. Matthew, good. Shh, hold on. 4.5 to the other side. Sine of 2 degrees, 45 minutes. Minutes, not degrees, lo siento. There we go. So there's no other math to do in isolating what's unknown besides multiplying 4.5 to the other side, because everything else, I think you were just reading it for you, Matthew, which is good. Sine of 2 degrees, 45 minutes over 6.8. That was already there. I'm not doing any of that extra. It's just there. I'm moving 4.5 to the other side. But the problem is when we plug that into our calculator, why aren't we done yet? Yeah. But how do you undo sine? Which is what my hint was. If you're not using sine inverse, I'm not sure how you're getting to A. Because the only way to get to A is to go ahead and do sine inverse at both sides. And the nice thing, guys, is if you just you could have plugged this in all at once. Doesn't mean you're wrong if you did it in a couple steps. But I'm just going to go ahead and throw in second sine of, do you guys remember how to make a nice pretty fraction in your calculator?
Math all the way over.
I was thinking alpha y equals, that cool little box over box shortcut. Oh, that works too. That works too. But it's a little bit faster, alpha y equals, but it's up to you. And then you could go ahead and plug in your 4.5 sine of 2 degrees. Go to that second apps menu. If for any reason you're stuck at this point, don't know how to plug in, reach out to your group. Ask me if your group is stuck. Over 6.8. And I think, well, you guys tell me and I'll see if I'm right. What'd you get? I got 1.82 also. And I'm in degree mode. That's kind of weird, huh? Are you in degree mode? Okay, let me see your calculator. That's okay. Oh, see, I would do it all at once. When we start doing it in little bits and pieces, and I see you somewhere, Matthew, you're dividing by 2, sine of 2. That's not good. It needs to be sine of 2, not with a division after, not before. So try to plug it in all at once. It really does make things better. 4.5 times sine of 2 is 40 divided by 6.8. I got 1.82 also. Did anybody get anything besides 1.82? I'm doing this really quickly another way, making sure that the APSI thing, 4.5 times sine of 2. Yep. So my angle A was, if we're rounding to 2 decimal places like they're telling us to, that's a tiny angle, huh? So we had 2 angles. What can we do with 2 angles, cool kids? Yeah, go team. 180 minus the first angle of 2 degrees and, oh, it's a little annoying to go get the minutes, huh? That's okay. We got this. Subtract the 2 degrees, 45 minutes. Subtract the, we could do 1.82, but it might be nicer if you go use that whole big old decimal, because you guys can go up and steal the big old long guy, right? Because then it's a little bit more precise. And for my, yeah, I'm getting the same thing, Jason. You guys getting it too? 175.43 degrees? What are we missing now? Ah, side C. Good. So we have angle B with side B. We have angle A with side A. Angle C with, side C. Oh, but hey, how am I going to reorient my sine formula now?
Oh, but
Yeah. Well, let's do the side on top. Now, because I have to go solve for side C, I'm going to have to use that nasty angle C from right over here, right? But what do you guys think I'm going to try to do to try to eliminate as much error as possible? I'm going to use B, not A. Good. And when I use angle C, do you think I'm going to use the rounded one or the big nasty one? Yeah, let's use the big one, because that way we have less error, right? So when I go ahead and plug in, moving the sine C to the other side, I can say little side C is equal to sine of, I'm going to put 175.4305 dot, 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 to show you guys I'm trying to use the big old one. When I multiply by sine C on both sides, I have to write the rest also. So I'm going to need side B, which I know from up above is 6.8. And I'm going to divide by sine of B, which is sine of 2 degrees, 45 minutes. And then I'm plugging and chugging all at once. Nice thing is we don't need any sine inverse because we're not solving for, we're solving for a side. So sine of the big old nasty guy times 6.8 divided by sine of my little annoying 2 degrees, 45 minutes. All right, what'd you guys get? Who beat me there? I got 11.29 because I used my big old decimal instead of the rounded one. Anybody else get the more precise 11.29? Okay. So I'm sure that the 0.30 was really close and you probably plugged it in perfectly. I just bet that you used the rounded instead of the big old guy. Now here's the dilemma. We got to fill in the blanks up here. Anytime you're given an SSA, there could be 0 solutions, 1 solution, or 2 solutions for the triangle. We solved for 3 guys. These components, the given 3 and the 3 that we found, what did they all make? How many triangles?
1.
Just 1. 1 angle A, 1 angle B, 1 angle C. 1 side A, 1 side B, 1 side C. So right away, do we know that it's not 0? Yeah, because we found one, and it's possible. The formula worked out. We know this is not a case where you have 0 possible triangles. In geometry, I think sometimes you got an impossible triangle or not a possible triangle. It's been a while. But impossible triangles can show up in this case. But this isn't one because we were able to actually solve. So it's either 1 or... How could there be another way of putting this all together? That's one way. That's one way. Let's go ahead and do another example, and I'll come back to this guy. This guy's going to be really hard because, do you guys know what kind of angle 2 degrees and 45 minutes is? How big is that? Okay, literally, do you know what this triangle looks like? It's going to be like a whoosh, 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 something like that. It's super tiny, super tiny. It's an awkward. Like it's awkward all over the place. So we'll come back to this guy because this is a really awkward one for me to draw and for you guys to visualize. Let's try another one, and then we'll come back to this one. Let's try another one, then we'll come back. Oh, I don't want to try that one. Do I want to try this one? Hold on, give me a sec. Ugh, I don't want to use that one either. Where are my good examples? Hold on, hold on. This one's good. Let's rearrange. Let's use this one instead. Okay. All right. I want you guys to actually draw this one for me, at least approximately, using what you know. I'm going to draw it a little bit more precisely using what I know, because I'm going to grab my really cool like electronic protractor. What? Go team. I know. It's cool. Oh, now it's not. Now it's annoying. Okay, there we go. But you guys are going to go ahead and draw this as best you can, 76 degrees, if you want to see me do it. There we go. There we go. 76 degrees. Then we have a length of 18. I'm going to grab up my ruler. 18, let's see, what do I want to measure in? Let's not do inches, that would be bad. Centimeters, it's not too much better. Let's do half centimeters. I know that's awkward, but it'll work. So 18 half centimeters, that would be 9 centimeters. All right, 18 half centimeters. And then let's use 20 half centimeters. Which would be 10. It's a little shy, I'm a little bit over. I think that's about right. Okay. So if this is an ABC triangle, right away I know I'm going to put B right about here along my 76 line. Okay. So I'm thinking about an A, B, C triangle where I know 76 and I know 20 and I know 18. But what's the dilemma if you guys actually like wrote this? 76, you made it kind of like a little bit less than a right, and then you went ahead and made 20, and then you made 18. Side, side, angle. Sorry, side, side, angle, or angle, side, side. I went ahead and measured this. So I actually have this being 20. I actually have this one being 18. Measurements of something, I called them half centimeters. What's the dilemma if I actually try to go connect this right now? What do you mean it's too short? Uh-oh. Why isn't it possible? In this picture it looks possible. But what's true? Do you guys know the shortest distance between any two objects? Straight line, right? The straight line would be, okay, here's your angle of 76. What's the shortest distance from top to bottom? It would actually be a right angle. It would actually be a right triangle. Now remember, no guarantees is a right triangle. What's the shortest possible distance if I had 20 for this opposite side? I know they told me this is 18. But what would be the shortest distance? You could actually pretend it was a right triangle to figure out the shortest distance. And we could say, okay, hold on, opposite over hypotenuse, that would be sine, right? Sine of 76 is equal to x over 20. Can anyone plug in their calculator really quickly? What's 20 times sine of 76? What's the shortest distance between the purple side and the bottom of the triangle? 19.41. What's the circle of that and the side they gave me? They don't add up. So if you were to actually have rulers and protractors, you could actually take the given information they give you, and you could notice yourself, uh-oh, that thing, if I'm going to swing it, isn't it going to fall short? Like, I don't know what this angle is. They didn't tell me what angle, what would that be? Angle C is, right? They didn't tell me who that is. He can be anybody. But if I was to take this and if I was to be like, okay, well, what if I tried really, really hard? Right? If he keeps swinging, what's going to happen? He's not going to hit. Can I make a possible triangle with this information? No. But wait, what's the title of section 6.1? Law of, not law of Pythagorean theorem, let's pretend. So what if we had plugged this into law of sines? Wouldn't you guys have done sine of b over b? Equals sine of the guy that you know, 76 over 18. Let's see if we have to get protractors and rulers for everybody for their homework, or let's see if maybe law of sines will help us in situations like this too. What happens if you start solving? Some of you already have. It gives an error. So we would have multiplied the 20, sine of 76, trying to catch people up that didn't go ahead, but good job, it just said error. Sine inverse of. Now, I'm going to be a little weird on this one. Usually, I just plug it all in. All of it, all of it, all of it. Where's my calculator? Usually, I plug it all in and say, sweet, there's an answer. But this time, just to show you what's going on, I'm going to do the 20 sine of 76 divided by 18 first to show you why it's an error. 1.08. Why is that always going to be bad? Anything more than 1. How low does sine and cosine go? 1 and negative 1. Can sine ever be anything big? Can that side ever be longer than the hypotenuse? No, hypotenuse side. Oh. With law of sines, without having to draw a picture, without needing protractors and rulers? Oh, sweet. This is not possible. They give you an angle, side angle, a side angle, side, a side, 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 a side angle, side. All of those will always be possible triangles. But if they give you side, side angle, it doesn't always work. Because if they give you a side, no matter what the angle is, a side that's too short and can't possibly connect, doesn't matter. So we saw a case that's an impossible triangle with 0 possible solutions. We saw a case that has really weird angles, and it's really hard for us to visualize. So we're like, okay, well, I get the 0. The 0 is going to be, the 0 possible triangles is going to be an error. All I have to do is plug into law of sines. No big deal. So how do I know the difference between 1 or 2? And who is this guy? Does he only have 1 possible solution or 2? Now let's go check out this guy. Now let's go check out this guy. Right away, you guys might notice they drew a picture, but be careful. I was able to draw a picture in the last example, and I'm like, oh, hey, right? It's a possible triangle. And then if we made everything accurate, no, it wasn't. So be careful. Just because there's a picture doesn't necessarily mean it's right. But, oh, what do you notice about side A and angle, sorry, side B and side A right now? Is this guy going to be too short? It might be too long. Let's think if that's ever a thing. Okay, we don't know what angle C is. He can be anybody. This side can swing, right? But if we were to find the height, which we could do, we could find the height using law of sines, using Pythagorean theorem, and find the h of this triangle using 42 degrees and using 12 inches. If someone wouldn't mind really quickly plugging in, I'll get it for you, h over 12. 12 sine of 42. What's the height or the altitude of this triangle? 12 times sine of 42. Okay, if this side was shorter than 8.03, I'd be in trouble. It'd be swinging, and it wouldn't be able to connect. So right away, I know it's not impossible. So too long actually isn't a thing, because however long this is, can't we always make a triangle? Just that bottom side would be longer? And did they tell us anything about how long C has to be? So even if this was like, I don't know, a mile long, which would be super awkward, But that C would just have to be super, 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 super long to meet it. But any length is okay as long as it's bigger than 8.03. If it's shorter than 8.03, if it's shorter than the little right triangle, then I'm in trouble. If it's shorter than the height. But as long as it's okay. We're still trying to one solution or two solutions? One solution or two solutions? Okay, I want you guys to throw into law of sines. Go ahead and practice one more time. Throw into law of sines. You guys should know who you're going for. Who are you going for if you have angle A, side, yeah, go find angle B. Finish off this triangle. I wonder if there's any other way to draw this. I wonder if there's any other way to draw this. I'm going to freeze the screen really quickly to set up a side-by-side comparison as to an example of 1 and an example of 2. Okay, I'm going to go ahead and set it up too. Hopefully you guys are getting angle B by taking sine inverse of both sides. Using your sine of B over B equals sine of 42 all over 22. 12 sine of 42 all over. Angle B. Do you guys get 21.41? Double check what you plugged in, but when you plugged in, you're multiplying 12 by sine of A over A, or 12 times sine of 42 over 22. Angle C we can find pretty quickly by subtracting from 180. Double check your calculator work. If for any reason you're off, totally okay. Angle C is 116.59. Side C, we would go back to law of sines again. Sine of 116.5936. I'm showing you I'm using the big guy. Equals, I'm going to use my A with A again, just to make it all nice and precise. So 22 over sine of 42. With some pretty quick law of sine work, hopefully you guys know that I'm going to multiply him to the other side. I'd have sine of the nasty guy times 22 divided by sine of 42. I think I get 29.40. People that beat me, are you agreeing? I'm going to show you why in just one second, but this is a one possible triangle case, which means that we are totally and completely done with him. But I'm going to show you a case as to when it would be 2, and let's compare and contrast. What if everything was the same? Angle A was the same, side B was the same, but side A was 10. It's not too short. It's bigger than the 8.03, but it's also not too long. It's not too short, but it's also not too long. Here's the crazy thing. We would actually solve this guy the exact same way, except instead of using 22 for A, we'd use 10. So everything is going to look super, super similar. Nothing in your calculator would warn you saying, ding, 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 there are 2 possible triangles, not 1. When you would go ahead and solve, you would multiply the other side by 12. You would take sine inverse of both sides just like you did. So I'm going to do the exact same thing, except anywhere there was a 22, what is it now? Okay. Careful. Yeah, 10 is what changed. So I'm going to solve it the exact same way as I did over there, except this time when I go to do sine inverse, I'm going to have 12 sine of 40. It said, only one answer, no big deal, 53. I'm going to go ahead and find my angle C by subtracting from 180, just like I did over there. But now with the new angle and my 42. The calculator isn't warning me that there's more than one answer. 84.59. And then side C, I'm going to find very similarly, setting it up, C over sine of my 84.59, 5866, dot, dot, dot. Has anything changed yet, guys? Except for my 10? So why is this guy 2 possible triangle instead of a 1 possible triangle? Let me finish plugging in. Sine of 84 point blah, blah, times 10, moving him to the other side, divided by sine of 42, 14.88. Done. Or, what's different? Can you guys visualize with me for a second? This information and this triangle. This is exactly the same. We have 12. This is exactly the same. We have 42 and we're not sure how long he is. So let's just draw a big old long line, and if he gets cut down, whatever. What just changed?
Angle C.
Angle C changed because side A now became a little bit less than 12, right? About 10-ish? I'm going to put a little dash. Which is almost a little bit less than half of that, right? Okay, so if I have a 10 instead of a 22, is it going to have the exact same angle to hit? No, because he stops right there, right? So what angle is going to hit with him? I think it needs to be a little bit longer. So what if I was to rotate him? How many ways could he connect? Can he hit? Yes or no? Yeah. Where? Right here. Does that make sense with my 50, wait, my 84-ish 0.59? Does that look almost like a right angle? Yeah, super close to it, right? But here's the problem, guys. That's one way to hit. There we go. I established it. That's one way to hit. But what's another way to hit? What if I had kept going? Is there another triangle? Ooh, check it. There are 2 different triangles. Now one's super awkward. I totally understand. But this is actually a possible triangle also. That's a possible one, or this is a possible one. So how do we find it? Here's your or. Ready? Or angle B is equal to 180 minus the one from up here, 53.41. It has to do with properties of sine inverse. I don't know why the bell didn't ring. It's a great question. You guys didn't hear a bell ring, did you? So here's the dealio. Well, chapel's been letting out late, so it's possible they're giving us a couple extra minutes because I don't hear anybody in the hallway either. There we go. Pause, pause, pause. I just want you guys to see track. Could 126.59 also be angle B?
Yeah.
Yes. But guess what you would have to do? Find a new angle C and find a new side C. How? Using the exact same method. How do you know which one's which? Check 180 minus, and if the 180 minus can combine with the original and leave space for a third angle, there's 2 cases. I want you guys to see tonight with essay. The zeros are easy because it's going to say error. The ones, the 180 minus isn't going to work. The 2s, the 180 does work. We'll powwow tomorrow how it goes. It's weird with the bell. Threw me off. Bye, guys.